guys? I'm Ivan Jefferson Nanyos, and for now I'll be your math teacher, and we will talk about the number theory. And please lend me your ears in order to gain more knowledge and learn about my topic. So let's get started. So number theory. For sure we all know what is a number, right? So number is used to count, evaluate, calculate, or represent a quantity. So what comes to your mind if you hear the word theory? So theory, it is the set of statement or a principles devised to explain a group of facts or a phenomena. In short, it is an unproven concept. What is number theory? So number theory is the branch of mathematics that deals with the properties and relationship of a number, especially for the positive integers. It is written by William Dunham, the professor of mathematics in Pennsylvania. So, according to Carl Friedrich Gauss, mathematics is the queen of sciences and the number theory is the queen of mathematics. So, for now, I will show you the examples of a number theory. First, we have here a natural number, also called a counting number. So note that 0 is not included to a counting numbers. So next we have here the whole numbers starting to 0. So it is the number that cannot have a fractions, decimals, square roots, exponents, negatives, and also a pi. So at this time 0 is included. So numbers like 1/2, 1.1, and 3.5 are not included. So next we have here an integers. For example, plus or positive 55, negative 6, negative 10, and positive 58. Whole number and their opposites, which includes minus and decimals. So next is the rational numbers. So any number that can be written as a fraction or ratio of two integers. So for example, 1.3, 3, 5, and 7.5. So note that the denominator cannot be a 0. So next is the irrational numbers or a transcendental numbers. So if a number cannot be written as a fraction due to decimal points being infinite, it is called as irrational number. Any square root that is not a perfect square root is an irrational number. For example, 3.14 or the pi and 7.66 etc. and the Euler's number or constant. So next is the real numbers. So every number on the number line. The set of real numbers includes all rational and irrational numbers. Example, 1, 12.38, negative 0.8625, 3/4, square root of 2, and 1998. So next is the factors. So if a number has only two factors, that number is a prime number. So for example, the factors of 16 are 1, 2, 4, 8, and 16. So next is the composite number. A whole number greater than 1 that has more than 2 factors. So for example, 4, 6, 8, 9, 10, 12, 14, 15, and 16. So next is the odd numbers. So odd numbers is also a component of a number theory. So what are the number odd numbers. So those are the 1, 3, 5, 7, 9, 11, and so on so forth. So next is the even numbers. So even numbers, those numbers can be divided exactly into 2. So next is the square number. So it is the product of an integers by itself. So for example, 9 is a number square. So since it is equal, so it it can be written by 3 times 3 cube. So the cube of a number or any mathematical expression is denoted by a superscript 3. So for example, 2 raised to 3 is equal to 8, or x plus 1 raised to 3. So next is the prime number. So it is a number which can be only divided by itself and 1. So examples are 2, 3, 5, 7, 11, 13, 17, 19, 23, 29, and 31, and so on. So next is the negative numbers. So negative numbers are less than 0. So the reason for having negative 0 numbers is because when the weather colder than 0 degrees Celsius, the water freezes. So colder temperatures are denoted as negative. So negative 10 degrees Celsius is 10 degrees below 0. So next is the triangular number. So a triangular number or a triangle number counts the objects that can form an equilateral triangle. So next is the perfect number. So perfect number, a positive integer that is equal to the sum of its proper divisors. The smallest perfect number is 6, which is the sum of 1, 2, and 3. Other perfect numbers are 28, 496, and 8128. So perfect numbers were deemed to have important numerology by the ancients, and were extensively studied by the Greeks, including Euclid. So next is the Fibonacci series. Each number in the sequence is the addition or sum of the two previous numbers. So it just like form a pyramid. So the examples are the 0, 1, 1, 2, 3, 5, 8, 13, and 21, so on. So next is the consecutive integers. Integers that follow in sequence. For example, 22, 23, 24, 25. Consecutive integers can be more generally represented by n, n plus 1, n plus 2, n plus 3, n plus 4, and so on. They follow similar pattern. So next we have here the imaginary numbers. So imaginary number. Square root of negative numbers are called imaginary number. Imaginary numbers are not really imaginary. They have a purpose to fill gap in a mathematics. So for example, the square root of negative 9 is equal to the square root of 9 times negative 1. So equals the square root of 9 times the square root of negative 1 is equal to 3 times the square root of negative 1. So since we got the answer of the square root of 9, so we bring down 3. So times the square root of negative 1. So it will be the imaginary. So equals 3i. 3 imaginary. So next is the complex number. So complex number is a combination of a real number and a imaginary number. So for example, 1 plus I, 39 plus 3i, 0.8 minus 2.2i, negative 2 plus pi I, square root of 2 plus pi all over 2. So that's all for now. Hope you learn and understand what I've discussed. So what are the components of the number theory? So those are the natural numbers, also called the counting numbers, whole numbers is starting to 0, the integers, the irrational numbers or transcendental numbers, real numbers, factors, composite numbers, odd numbers, even numbers, square numbers, cube, prime numbers, negative numbers, triangular numbers, perfect numbers, Fibonacci series, consecutive integers, imaginary numbers, and the complex numbers. So by the way, I'm Ivan Jefferson Nanyos, BSE Math, and thanks for watching.